All right, guys, today we're going to talk about factoring sum and difference of cubes, okay? Before we actually talk about how to factor those polynomials, I do want to touch base with you on where does this fit in things you already know, okay? So a couple things. Number one, you already know how to factor something that is two terms, right? So if it's two terms, there is one way you already know how to factor, and that happens to be difference of squares. Oops. Okay, difference of squares. Okay, if it's three terms, you can use guess and check, split the middle term. I prefer guess and check, but again, at three terms, you know how to solve something that has three terms. And then, so I'm just going to put guess and check here. Okay. And then four terms, we use factor by grouping. Okay. So when it says sum and difference of cubes, hopefully you're thinking in your head, terms are separated by addition or subtraction. So I'm dealing with a binomial or something that has two terms. Okay. So before you got into this class, if you saw two terms, the only thing you looked at was, hey, is it subtraction? Are they squares? All right. If they are, then let's factor it. If not, then I'm done, right? Well, now with this class, we're going to add something else inside of that two-term box, okay? So what happens if the two terms happen to be perfect cubes? If the two terms happen to be perfect cubes to begin with, we would use this rule, okay? And the rule is this. I wouldn't get so caught up with memorizing all of that. There are a couple things, though, that I would make sure that I did know, okay? On my paper, anytime I've recognized that two terms are indeed perfect cubes, what I would do next is write down these expressions. I would write down A, B, and then A squared, AB, and B squared, okay? All right, because that happens to be the expression you're going to use all the time, no matter if it is a sum of cubes or a difference of cubes, okay? If you notice, in that box, both of them have those terms in there. The only difference is their signs, okay? And their signs are predicated on what you start with, okay? So before we actually dive into a problem, I do want to give you an acronym that will hopefully help you remember. That acronym is SOAP, okay? So the S in SOAP stands for same. The O in SOAP stands for opposite. And then the AP in SOAP stands for always positive, okay? And the signs are predicated on what you start with. Okay, so before we dive into an example, I just want to kind of explain it, okay? In this particular, example letter A, we are left with x to the third plus 8. Both of those are perfect cubes. So in this particular sum and difference rule, we know that the first factor of my two factors has the same sign as what I start with. So in this case, there would be a plus here. Does that make sense? Because in this particular case, we started with a plus, so we have the same sign. Opposite would mean opposite of what you start with. So opposite of what you started with in this case would be a minus. And then always positive in this case, doesn't matter which case it is, you know you're always going to have a positive at the end. Okay, so SOAP is the word that I would like for you to remember so that you don't lose track of signs. Okay, remember those terms, AB, A squared, AB, B squared, and then inside of them, the signs are predicated on your first term. Now, hopefully somebody in here listening to this video is thinking, well, Mr. B, how in the world do I get my A and my B? Well, guys, if we take a look back here at the beginning, up in this box, you start with a to the third minus b to the third, or a to the third plus b to the third. So both of those terms are perfect cubes. So the question is, how do we go from a to the third to a? I know everybody answered in unison there. You would take the cube root of both of them, correct? Because if I were to take the cube root of a to the third, right? I need groups of 3, so that's a times a times a. I have one, I pull one out. So the cube root of a to the third is just a. So in order to find my a and my b term, all I would have to do is take the cube root of each. Okay, so in this particular example, in example A, I'm going to take the cube root of x to the third, and that will give me my a term. I'm going to take the cube root of 8, which will be my b term. So the cube root of x to the third is x. Cube root of 8 is 2. So once I have my a and my b, all I have to do now is substitute it into the rule. So the first factor of those two factors is a plus b. So my a is x. My b is 2, so that's x plus 2. Okay? The second factor, the first term is a squared. So x squared is just x squared. Again, it's minus, it's opposite because we started with a positive. It's a times b, so that is 2x. And then b squared, so 2 squared is 4. Okay? So this right here would be my answer. These are the two factors I get when I factor x to the third plus 8. If we were in class, I would show you something cool, but I'm trying to keep this video as short as possible. So just know that this factor right here is always prime. Okay? That is never going to be factorable. I hope everybody in here was like, oh, that's quadratic. Maybe I can factor that thing, but you cannot. Okay? So that is always prime, that factor. Okay? Keep that in mind. When we get into solving, that'll be important. Okay? All right, let's move to the second example. I would strongly encourage you in the second example to maybe try it first and then see if it matches what I have. All right, so again, if I were you, I would write down what we talked about. So that is a squared, ab, b squared. Once I have identified that each one of those are perfect cubes, I'm going to write this down. Okay, and then all I have to do is remember the word SOAP. Remember, that's an acronym for same, opposite, always positive. Okay, the signs are predicated on what you start with. So this is x to the third minus 64, both of which are perfect cubes. I start with a minus, so same is minus inside. Opposite would be opposite of what I started with, so that would be a plus. And then always positive would always be positive. Okay. Now, the last thing I have to do is just find my a and b. And remember, if you just look up top, in order to find a and b, all we have to do is take the cube root of each. So the cube root of x to the third is x. So my a is x, and my b, the cube root of 64, happens to be 4. Okay, and once I have all that information, it becomes quite easy, correct? All you have to do is plug it in. So x minus 4, and then x squared, a times b is 4x, and then b squared would be 16, okay? So those are your two factors. That is your answer for example B. All right, moving on to C. Again, what I would do is write my a, b, a squared, ab, b squared, okay? And then I would think of SOAP, okay? So you're always going to write this down, and then I would think of SOAP. SOAP. S stands for same. Again, it's the same as what I start with. So that's a plus. The O in SOAP stands for opposite. So it's the opposite of what I start with. And then the AP is always positive. Okay? And then the last thing I would do is find my A and B. So A is equal to X. B is equal to 3. Again, A and B you find by taking the cube roots of both terms. So plug it in. That's X plus 3. And then x squared minus 3x plus 9. Again, if I were you, I would try to pause the video and see if I could do D and E by myself. All right, here we go with D. D. I know I sound like a broken record, but guys, we got to make sure we do this, okay? I'm going to write A, B down, and then A squared, AB, B squared, okay? If you write that down first, that's the same no matter what. Once you've identified that they're perfect cubes. Next, I'm going to think of SOAP. And again, same as what I start with. So that's a minus. Opposite of what I start with is a plus. And then AP is always positive. okay? Last thing I have to do is find my a and b value, which means I'm going to take the cube root of each one of these things. Again, I'm not taking the cube root of the minus sign. These signs are taken up by the SOAP acronym, okay? So I'm only taking the cube root of the positive numbers, okay? So cube root of 125 would be 5x. Cube root of 8 is 2. So now all I'm going to do is plug that into the formula, or the rule. So 5x minus 2, and then a squared. Guys, I will tell you, what I'm about to write down is wrong. That is not 5x squared. That is by far the most common mistake kids make. Make sure that's a squared, right? So you have to square the entire thing. Remember, squared is 5x times 5x. Therefore, a squared would equal 25x squared. That is by far the biggest mistake. Kids typically forget to square the 5 and they just put 5x squared. Please do not be that person, okay? So inside of here should be 25x squared. I'm going to add AB, which is 10x, and then add 2 squared, which is 4, okay? So there is my answer. All right, E's the last one, and hopefully this stumps you guys a little bit, because before you factor this, again, I don't want you to get into a pattern of, oh, these are all perfect cubes. Yes, the ones that we're doing on this particular paper are perfect cubes, but on a test, a quiz, just at any time, you're going to be faced with all kinds of different factoring, so you have to be able to know when to use what. So hopefully, E, you stopped for a second, and you were like, holy cow, 16 and 250, they are not perfect cubes. So I potentially might not be able to use sum and difference of cubes. But I think, or I hope, everybody in this room knows that every single time you factor, every time, the very first thing that you do, no matter what, is pull out a GCF. You're always looking to pull out GCFs because GCFs, number one, are going to make all your numbers smaller, which makes it easier to work with. And number two, if you pull out a GCF, you potentially might be able to factor it a different way. Make sense? Okay, so the GCF in this particular problem is 2. So I'm going to rewrite this as 2, 8x to the third plus 125. Now, notice, if I pull out a GCF of 2, do I now have 2 perfect cubes? You're darn tootin'. And when I see 2 perfect cubes, I will then rewrite my rule, which is AB is my first factor. My second factor is a squared, AB, b squared, right? Okay? Then I'm going to think of the word SOAP. SOAP, the S stands for same. So the same is what I start with. I start with a plus, so I have a plus. O stands for opposite. I start with a plus, which means the opposite of a plus is a minus. And then AP is always positive. Okay? Now we get to do exactly what we've done the previous 4 examples. So the cube root of 8x to the third, A, would equal 2x. The cube root of 125 is 5, okay? Again, I'm not going over that specifically on this. You can always rewrite that and factor it out if you would like, but I hope the majority of us can do that in our head or potentially use a calculator, okay? Here we go. If I plug in A, that's 2x plus 5. If I plug in A and B into the second factor, 2x squared. Remember, again, it's 2x squared, which is 2x times 2x, which is 4x squared. The most common mistake, and I said it in the previous example, I'll say it again, the most common mistake, and I'm sure, and I hope you guys pause the video, try to do the problem, and come back. I bet if you paused the video and came back, somebody, sorry, I just had to do that, would get something like this. Do you guys understand that? Okay, and that is not right. Okay, you have to make sure you square both of those numbers. Okay, so the answer for a squared should be 4x squared. Okay, so 4x squared. Okay, minus AB, so 2x times 5 is 10x. And then b squared is 25, so plus 25. So the one thing that we cannot forget, though, guys, remember, is we pulled out a GCF of 2. So you have to make sure you bring down that 2, and that is another factor of our original polynomial, okay? So when we say factor, we mean you need all of the prime factors, and 2 happens to be a factor, okay? So make sure you do not forget the GCF you pull out at the beginning.